Hi, thanks for having you here in our channel, Networks Diverse Talks, where in this video I'll be introducing or configuring a simple topology of eBGP with the multi-hop. As we know that the BGP is an exterior routing protocol. It's composed of both the eBGP and the IBGP, where the eBGP we will be peering between two devices or two routers that are in different ASs, unlike the IBGP where we'll be peering between two devices or two routers that are within the same autonomous system or the same ASs. In this topology, assuming we have two routers here, two branches, two sides, the R1 and the R2 here, and in between them there is the hop, which is the ISP router, assuming like that. First of all, I'll be configuring the interfaces with the IP addresses. Then we'll be configuring the BGP here, peering with this site. Same will go for this site. We'll be configuring the BGP peering with the other site here. For sure, configuring the multi-hop eBGP multi-hop in order for the establishment or for the peer to be established successfully. And also we'll be just configuring loopbacks on both sides and advertising the subnets from one side to another side and testing some comments to see how everything's working fine. Let's start. Alright, so first of all I'll be configuring the interfaces on each router first of all. So let me configure this interface first. Okay, I'll be choosing the IP 192.168.1.1 with a subnet mask dot 30/30.252. Okay. Interface is up. Let's go to the ISP router. We'll be configuring both interfaces. For sure, the G1, which is facing R1, should be within the same subnet. I'll be configuring it as 1.2. And the second interface here will be configuring a new subnet. We'll be choosing 192.168.2. Okay, .2.2. Assume 255/30 as well, and not shut. Okay, both are up. We'll go to R2. And here's one interface to configure. .1 because they're already on the connected interface. I configured 2.2, so here will be 2.1/30 as well. Okay, it should be going up. It's up. Let's also anyway like configure the loopback interface, which is like considered to be on the LAN section, as if we have a LAN section which we need to advertise it within the BGP, but we'll be configuring here the loopback. Okay, we'll be choosing 10.10.10.1. Whatever, we can choose /32 /31. It's a /30. We can consider it like that, like this. It's already up anyway. No need to unshut. Okay, and here I'll be configuring other loopback as well. Okay. All right. Right now, let's start to configure the BGP peering between both routers, between R1 and R2. We'll go to the config mode. In router 1, we are having the AS 500. We'll start to configure or peer with the second neighbor. Our second neighbor, which is where we need to peer with this interface on R2, will be 192.168.2.1, which is on this interface. And the remote AS is 600 on the second side. We'll be advertising the loopback here in order for the second router to receive it from the first router. We need to advertise it. Network 10.10.10.0 mask. Okay, let's do the same thing here. Here we'll be peering with the second side here on this interface, which is 192.168.1.1 remote AS 500, and we'll be advertising the loopback as 52. Okay, assuming that we need to check the neighborship right now, for sure it will not be established because anyway there is a hop in between these two routers. These are not connected directly with each other, so there is a hop in between them, and we need to configure the eBGP multi-hop. So there will be no establishment actually. Let's just verify the same. Summary. So as we see, it's idle. We cannot establish the connection between both of these routers unless we configure the eBGP multi-hop. Let's configure on this the eBGP multi-hop. To .1. So the eBGP, the multi-hop, in order to reach from R1 to R2 is actually two hops where there is an intermediate router in between. So first hop and then the second to reach the destination. Same goes from here as well. To reach to establish the peer with the R1 needs two hops. The first hop, which is the ISP router, and the second one reaching the destination. So it will be two hops actually. Same will go on here. 2. But still, the peer will not be actually established. Why? Because we need to be configuring the static route anyway. In order to reach this side from here, we need to configure a static route from here. Same goes on this side as well. In order to reach this section, we need to configure a static route from here. So let's configure the static route. In order to configure this subnet, in order to reach this subnet from here, this subnet will be 192.168.2.0 255.255.255.252 from this gateway, which is 192.168.1.2, right? This is the static route here, and from here, in order to reach here, same concept. Dot 1.0, and from this gateway, which is 192.168.2.2. Let's need to check one thing. Okay, right. Okay, so as you can see right now, the peering is established, and we are already learning from here. The peer is established with R1, and we are learning the loopback subnet from here, which is one subnet learned from the remote end. And you can see here that the uptime of the peering is already started, and right now it's increasing. So the peering is already established. Same goes for here. You can see also that we are establishing a BGP peering with a second hop on the second side, and also learning the subnet. Let's do some testing. Like, we need to try pinging the second loopback from here. It's 11.1. Okay, it's not pingable. Let's do a trace route. I don't know why it's not to understand why it's not pingable actually. So as you can see, it's stopping on the ISP router, so it seems that something missing here. Let's do the same from here. But one, right? The second loopback. For sure, it will not be reached as well. So let's verify. It's also stopping on the ISP router. So anyway, we need to add something here on the ISP router in order to make sure that everything should be working fine. We can add an IP route, let's say. Let's try adding this. Like, in order to reach both branches, we can do that. In order to reach this loopback, sorry, okay, it will be going through this gateway, which is 192.168.1.1. In order to reach the loopback, which is configured on router 1, be going via G1 here. and the second one will be .2.1, and here will be 11.0, right? 192.168.2.1. So in order to reach that loopback here, we'll be going via G1 here. Let's verify right now whether we'll be able to ping. So right now we are able to ping both sides, as you can see here. On the other side, 10.1, we're able to ping. We'll be verifying again the peering. We're able to learn one from there, and from R1 we'll be able to learn from R2 the subnet for the loopback. So it's only one subnet we are learning, because anyway we are advertising one subnet from branch to another. Let's test via trying some comments. Like we need to check what are the subnets that we are learning towards branch 1 from branch 2. Same goes for what are the subnets that we'll be learning on branch 2 from branch 1. Let's verify some comments, like show eBGP neighbor 192.168.2.1, which is on the second side. Received routes. Okay, so here I'm not able to display those information because at this error states that inbound software configuration not enabled. So in order to be able to see the subnet that we are learning here from the remote side, we need to enable the software configuration on this neighborship towards this side. So let's do that. Simply neighbor 192.168.2.1 software configuration inbound. Let's try to verify right now. As you can see, we are able right now, after configuring the software configuration inbound, to see what are the subnets that we are learning from the remote side, which is the loop /30, and the next hop will be this interface, or the IP 192.168.2.1. Let's verify the same from here. Show eBGP neighbor the remote end, which is 192.168.1.1. Receive the routes. Alright, will not be able to see that. Why? Same concept. We need to configure that software configuration inbound neighbor the remote end, which is 192.1 soft reconfiguration inbound. Let's verify right now. We are able to receive the subnet of the loopback from the remote end, which is 10.10.10.0/30, and the very next hop is the remote public interface here. It's a private IP, but assuming that it's an underlay, like in a real environment, it's an underlay link, and we have a public IPs, etc. But here, like, we are using the private IPs, sure, in the lab environment. So with the very next hop, which is 192.168.1.1 here. So here we have just introduced the eBGP configuration, the multi-hop, along with how we are learning advertising the subnets from site to site, and how we are able to see how that subnet is being received from site to another. and how we can like be able to see that by enabling the soft configuration inbound, reconfiguration inbound, and also we can on each side verify how what are the subnets that are being advertised from the site to another via the command, which is neighbor here 192.168 sorry .1.1 simply advertised routes. We'll be able to see that this local route is being advertised to the remote end, and here we can do the same. We'll be seeing 10.10.10.0/30 as you can see here. What can we also verify? The routing table, show IP route BGP. You can see here that administrative distance is 20, in eBGP it's a 20, in iBGP it's 200, but here we are already following the eBGP topology and the administrative distance is 20, or we can display to iBGP all, and we can see here that we are receiving this this subnet from the very next hop. Here the next hop is 0000 because it's on the local section, and here we'll do the same and we can see that we are receiving the remote subnet from the very next hop, which is 192.168.1.1. Also, if we can like advertise the or let each site reach any destination via like reach the consider that any site is a default gateway for the second site, we can configure the default originate, assuming that we need to consider this site as a default route for this site to reach their destination, or to consider this site as a default route for this site to reach their destination. We can configure on both ends in the BGP configuration the default originate by configuring the following: BGP 500 on this side, neighbor 192.168.2.1, default originate. Okay, so right now we have we are appearing with this neighbor and considering this site as a default originate for this one. So right now if we come here and check the routing table, okay, let me do that here. Check. Right now we can see that to reach any destination will be going via 192.168.1.1 here, and if we need to verify the same here, we'll be seeing that, okay, let me check what's going on here because it's not reflecting in a correct way. Let's check. no need to configure on both ends anyway. No need to configure on both ends. We can just configure on one end here while we peer with this subnet or with this site, and considering as a default originate, we'll be seeing the desired results here. Oh, it's having the same effect right now because anyway, I already removed the configuration from here, and I leave it on here. So since I already leave it on here while I'm peering with this neighborship and considering it as a default originate, I'm able to see that I'm reaching any destination from here, which is 192.168.2.1. But here I'm able to reach any destination from the local here. Default originate. Okay, right now here as we can see that there are two prefixes learned, the default any network 0000 and the loopback, which is advertised from the second branch. And here let's verify this. Are only able to uh, learn one subnet because anyway we have configured on here the default originate while we removed it from here. So we have only configured, eventually we have only configured the default originate on here. So from here we'll be able to reach any network from this very next hop, like the peering hop. But when we remove the default originate from here, we'll be seeing that we are not uh, learning it anymore. Like we are only learning one subnet from here. Assuming that we need to add it here back. Let's try to do that. Neighbor 192.168.2.1 default originate. Let's try to verify right now. It's one, should be true right now. But anyway, like it's not a proper use to be having the default originate on both ends, like assuming that this is a branch and this is another branch. Like on a specific branch we can configure, or assuming that this is an enterprise customer and this is an ISP router, and then there is an upstream router or whatever. On this router we'll be configuring, or in this router we'll be configuring the default originate. On the second router, no, like there is no need to configure the default originate in the real environment uses actually. But anyway, we can see right now that we are learning two prefixes here because we already configured on here again the default originate. So here we'll just a type it again. Sorry, go here. Okay, you can see that we are learning any destination from the very next hop along with the loopback. And here 192.168.1.1. So here receive routes here the same. We are any destination from this interface or this IP and the second subnet, which is the loopback. So when we configure the default origin while peering with this default originate here, and while peering from here to here with a default originate here, from each site will be able to go any destination via this default route. So here we already introduced how we configure the eBGP peering with a multi-hop, how we can enable the software configuration inbound in order to receive and see how we are receiving the subnets from one site to another site, and how we consider each site a default, like a default route for the second peering site in order to go to any destination. I hope that this video was informative for you, and thanks for watching.